Padma Bhushan Dr. Manju Sharma, Shri Alok Shriram ji, Shri Madhav Shriram ji, Shri Vijay Sardana ji, Professor V. Ramgopal Rao, the Honorable Speaker of today's function, guests, ladies and gentlemen. It is indeed a great pleasure for me to introduce today's speaker, Professor Ramgopal Rao. Although I personally feel that he needs no introduction, yet for the sake of the diversified audience that we had today, I would like to recount on his major credentials. Professor Rao is currently the Pillay Chair Professor in Electrical Engineering and the past Director of IIT Delhi. Before joining IIT Delhi as Director in April 2016, Dr. Rao served as a P.K. Kelkar Chair Professor for Nanotechnology in the Department of Electrical Engineering and as the Chief Investigator for the Center of Excellence in Nanoelectronics project at IIT Mumbai. Dr. Rao has over 480 research publications in the area of nanoscale devices and nanoelectronics, and is an inventor of more than 50 patents, of which 20 patents are from US. Out of his 50 patents, which he has got to his credit, 15 of these patents have been licensed for commercialization. Professor Rao is a co-founder of two deep technologies startup at IIT Mumbai, that is NanoSniff and Soil Sense, which are developing products of relevance to the society. Dr. Rao is a fellow of Institute of Electrical and Electronics Engineers, a fellow of Indian National Academy of Engineering, the National Academy of Sciences, the National Academy of Sciences, Bangalore, and the INSA, that is Indian National Science Academy. Professor Rao's research and leadership contributions have been recognized with over 35 awards and honors in the country and abroad. He is a recipient of 3 honorary doctorate degrees, and the recognitions of Professor Rao that he has received include the most prestigious Indian Santi Swarup Bhatnagar Prize in Engineering Sciences, Infosys Prize Award, Swarn Jayanti Fellowship Award from the Department of Science and Technology, Sir C. J.C. Bose National Fellowship Award, and so many others. Professor Rao was the editor for the Transaction of Electron Devices during 2003 to 2012, and currently he serves on the editorial advisory board of one of the most prestigious journals in the field of nanotechnology, that is ACS Nano Letters. Now, this is the 6th lecture of the series in Dr. Bansi Dhar Science, Technology and Innovation lectures. And we have listened to very profound talks from different personalities in the previous lectures, in the previous 5 lectures. Today, Professor Rao is talking on R&D to innovation, bridging the gap in higher educational institutions. And we are looking forward to this thought-provoking lecture. With this, I call upon Professor Rao to deliver his lecture, please. Thank you very much.
Thank you very much, Dr. Das. I would also like to thank Dr. Manju Sharma for considering me for this award, and of course the board of Shriram Institute. And I'm very happy to see Shri Alok B. Shriram and Vijay Sardana ji, Madhav Shriram, and all of you here. So I will share my presentation. I have made a short presentation. Yeah. I hope you are able to see this. It's all okay? Yeah. So I will talk in the next, maybe 35 to 40 minutes on at least my experiences of taking R&D to innovation. I will cover 2 aspects. One is my own experience as the director of IIT Delhi for 6 years and what kind of changes we brought about. So I think from the institutional perspective, how it has, actually in a way transformed the landscape, and how other institutions can also look at some of these initiatives and see how some of these can be implemented. And after that, I will talk about my own personal experiences and how I was able to translate some of these technologies to products. And I will also give you a glimpse of the issues that one faces and the startup culture and what one needs to do in order to promote such a culture in our institutions. I think India in a way is doing very well in terms of startups. If you've all been following news, over 100 plus unicorns now. I think the number is like 108 or 109 right now. But if you look at most of these technologies, one thing that is common is these are all mostly the business model innovations, but not really technology innovations. I think that you see as the common thread among all of these. And I think somewhere it needs to change. We need more product-oriented kind of companies. And that is where I feel there is a major role for academic institutions to play. And I hope to see, I think, such a thing happening now through the new education policy or whatever changes that we are bringing about in our higher educational institutions. If you look at the higher educational landscape in India, we have over 1,043 universities. In fact, this number maybe is 1 year ago. So now there may be a few more universities added, of which about 135 are the institutions of national importance. That is where IITs, IIMs, all these institutions fall under. And Shriram Institute, would also be among one of these kind of places. And if you look at the total number of students in our higher educational institutions, there are 38 million students pursuing higher education in India today. And out of these students, almost 50% are women or the girls, which is again a good sign because there is a good gender parity when it comes to higher education. And among these 38 million students who are pursuing higher education, we have about 200,000 students who are actually doing PhDs in our institutions and whose primary role is to do research. And these are the people who are always expanding the boundaries of knowledge. And India is indeed doing pretty well when it comes to the higher education landscape or the research landscape. But if you also look at the gross enrollment ratio of higher education, it's still not very good. If you look at it, the gross enrollment ratio in higher education is just about 27%. And this number is low compared to US, which is like 60%, or China, which is, like 50%. So compared to all these economies, we are not, many students are pursuing higher education in India. Only 1 in 4, go on to enter these universities and all that. Now, as part of the new education policy, the goal is to take this to 50% now. That is almost doubling our strength in the higher educational institutions by 2030, 2035 kind of a time frame. So in the next 10 years, hopefully, or as per the NEP sort of a mandate, our institutions will double their intake sort of a thing. So this is again a good sign. A lot of things are expanding. But like I said, India is also doing very well when it comes to research. India ranks 3rd in the world today when it comes to our research output. The research output is primarily measured in terms of the number of papers written in quality journals. These are all taken from good databases. Those predatory journals are not included here. So India's share of scientific publications is still low. Our comparison has always been with US and Japan. So US, for example, every 6th paper in the world comes from US, and every 5th paper in the world comes from China. Compared to that, every 20th paper comes out of India in these research journals and all that. I think so we are far behind the US and China. I think that is where we probably need a lot of catch up to do, and if we ever want to compete with them. And India is also one of the fastest growing countries in terms of scientific publications. We are growing at 11% right now as compared to the world average of 4%. So I think, if things continue like this, if we invest more money into our higher educational system, I think we have, very good chance of, joining the league of countries like US and China. We are, despite the very low spending on public R&D, in fact, we are spending, as my slide here shows, we are here, we are at the bottom of the table. This is R&D expenditure as percentage of GDP, for different countries. If you look at it, India is at the bottom of the table. Look at the countries like Israel, which is spending like above 4.5% of their GDP on higher education. Look at Korea, look at US, which is such a large economy. They are also spending somewhere in the range of 2.5% to 3%, close to 3% kind of a thing. And China, which is again 5 times our economy, is spending over 2%. So compared to the kind of investments that are going into higher education in these countries, we are spending pathetically low amounts of money. We compare ourselves with Pakistan, Philippines, Sri Lanka, Venezuela kind of countries. I think this is one thing that we need to spend more. Our budgets now for higher education need to go up by at least a factor of 2 to 3 in the next 10 years. But despite such low spending, if you look at the research output that is coming out of our institutions, we are ranked number 1. Per dollar terms, if you look at the research output, India ranks number 1 in the world today. I think that credit should go to our researchers, our academic institutions that way. But one complaint that has always been there is, while we have become extremely good at converting the funds that are given to us into research papers, but we are very poor while it comes to converting that knowledge, those research, the knowledge that these research papers contain back into wealth. So while one way translation is happening, the funds to the research and knowledge, the other way translation is totally missing, which is knowledge to wealth. I think that is something that needs to change now. So my talk is all about, how do we, essentially bridge that kind of a gap. For this to happen, for the knowledge to become wealth, I think the societal problems need to become projects in our higher educational institutions. So that is one culture that we need to, follow more and more kind of a thing. And that is something that is required. Whenever I show this data, the immediate question is, but what about the quality? We are writing lots of papers, but is anybody reading these papers? Is anything happening out of these papers? One way to judge quality is the citations. How many people have cited our work? If you look at India's position, this is my own data from Scopus. Anyone can get this data from Scopus. India, in any technology that you look at today, India is ranked anywhere from 3rd to 6th, 5th, 6th kind of a position. So we are among the top 10 countries when it comes to even the citation index, and which is a good sign. So in most of these technologies, despite the low spending, I think we are not only writing lots of papers, but our papers are also getting cited. So what it essentially means is we generate the knowledge, somebody else understands this knowledge and converts that into a technology or a product and sells the technology back to us. I think that is what has been happening, in India for a very long time. And if you even look at the highly cited scientific papers and the country rankings in that, in 98 to 2000, if you look at, these were the top 10 countries, where the highly cited scientific papers came from. And China was at the 13th position, and the US, Britain, Germany. So these were the top ranking countries. 2008 to 2010, 1 decade later, things have changed. China from 13th position jumped to the 2nd position and started, but far behind US, and Japan was here. And look at another decade later. China completely overtook US. Now China is actually, Chinese papers are much more heavily cited, highly cited as compared to US. So in 3 decades, look at the transformation that China has made for itself when it comes to the quality of research and all of that. And where does India stand? In a decade ago, we were nowhere on the scene, but thanks to the Indian research, the resilience, the temperament, the culture that exists in this country, we have now displaced Japan out of these top 10 countries, and we are now at the 7th position. So India now, despite such low spending on the R&D, it is still at the 7th position when it comes to the quality of research. I think, so that way, there is something that we all need to be happy about and proud about our country. But again, that knowledge to wealth translation is something that needs to become the mandate for the next year now. how does what stands between knowledge to wealth creation? What stands is the intellectual property protection. Now, how many patents are you filing in a way also helps you to realize, how much of this knowledge can eventually become wealth. And that is where, if you look at in my own area, nanotechnology, in 2019 data, when you look at, India is ranked third in the world when it comes to nanotechnology. We wrote about 15,000 papers, in the year 2019, and look at the US, 23,000 papers. Of course, China is way ahead, 74,000 papers. But for 23,000, 24,000 papers, look at how many patents, US has actually filed. And you see that the US has actually filed, close to 5,000 patents for about 24,000 papers. And look at India. India wrote 15,000 papers and filed 54 patents. What it essentially means is that for every 300 papers, Indians are filing about one patent. And while in the case of US, for every 5 papers, they are filing a patent. And one patent arises out of every 5 papers in the US, while that number is one patent out of 300 papers in India. I think that is something that needs to change, because unless we protect our IP more aggressively, there is no technology, nothing is going to happen, because if we don't even own the IP, we cannot claim that we have any exclusive kind of a technology development that nobody else can compete. I think that is where our institutions, of course, need to do better. We need to be filing more and more patents. And this again, if you look at, for example, the technology development strength, of different countries as per the Lux Research report, the report actually classifies the countries into 4 different quadrants. One is the minor league, the second is the niche players, the third is the dominant players, where most of the technology development happens, and the other quadrant is the high tower, the ivory towers, where they have, in some areas, they are undisputed kind of kings. And when you look at the nanotech activity versus technology development strength, right, in the nanotechnology area, which is my area of research, India is here. India is at the bottom of the minor league, where a lot of research is happening. But when it comes to development of technologies, we really don't do a good job. But the same also is true of Russia, Australia, Canada, and China. Even here, a lot of research is getting published. But their ability to convert that into technology is again not as good as what one would see in the dominant players like US, Japan, Germany, and South Korea. So India at some point needs to make that major leap, go from the bottom of the minor league to top of the dominant kind of players. And that is something, at least in the next decade, needs to happen. Otherwise, writing more papers and publishing more papers is not going to change anything for the common man. I mean, and therefore, at some point, the questions will be raised about, what has come out of this research. And that is what you keep hearing now, all the time in the media, asking about the contributions of academic institutions and all of that. But that journey that we need to traverse now, and which is very important. And the new education policy that has been unveiled in 2019, I call it the moral movement for India. Now, what is this moral movement? As I told you, in the last 10 years, Indian higher educational institutions are doing very well. A lot of research is happening despite the low spending of government funds. But however, when you look at the way the R&D is done in Indian academic institutions, most of it is still primarily driven by what is happening in North America and Europe. The way we pick up research problems when PhD students join, how do we do that? The student goes to library and then reads 100 papers and says that, this is done, something is not done. And the student, fills up that gap and publishes a few more papers. That is the way, at least, as per my informal survey among PhD students, at least 95% of research, depending on which institution you go to, I would think 70 to 100% of research, is actually carried out by picking problems from the library. So that is how most of the research is done. But for example, if you look at mid 1800s, the 19th century, the US was not the superpower when it comes to the knowledge generation or anything. At that time, the colleges in US were basically following England and Germany. That is where those were the countries which were considered as the prominent places for all the research that was happening. And the US universities were primarily following whatever was happening in England and Germany. That's exactly similar to how we do research today. So what US was doing, in those times was exactly how, we pick up our research problems today. And these countries in England and Germany, they were very well known for research on classics, on theology, on natural sciences. And the US universities were also following the same kind of areas. What changed for the US was this land grant university model, this act, which were introduced by Morrill in 1862. That is known as the Morrill Act. In 1862, US passed an act called the Land Grant University, where they basically said that for any university to receive any support from the government, whether it is land or any funds or anything, the universities need to work on such branches of learning as are related to agriculture and the mechanic arts. What basically US did was, if any university, starts to work on the problems of the society, because in those days, what the main avocation in the society was primarily agriculture, and the industrialization was just beginning to happen with steam power and all of that. So that is when US universities were told that you need to work and connect with the society for you to receive any land or any other kind of a favor from the governments. And that created a kind of a transformation in the US universities. Once they started connecting with the society, and now we know that most of the centers of excellence in any area you take, you would eventually find one of the US universities on the map. And that translation of that connection with the society is what has transformed the landscape for US universities. That's exactly what needs to happen with India. And with new education policy, if you look at the document, it's basically saying the same thing. And that is what, therefore, I call it the Morrill movement for India. And if you look at most of the research that is happening in India, I categorize in this second category, where solution looking for a problem. There is a lot of research happening, a lot of solutions are getting developed. But then once you develop a solution, then you start looking for a problem where I can apply that solution. The thing is very different, from solution to a problem. If you pick up a problem and then you bring all the resources together in terms of people, funds, and all of that, then working towards developing a solution to that problem, that is the kind of a research you would like to see in at least institutions like Shriram Institute or institutions like IITs. I think some of us who are the prominent institutions in this country, we need to move more towards this solution to a problem rather than solutions looking for a problem. And NEP essentially is a step in the right direction. If implemented in the right spirit, I think it can transform the Indian universities, and who knows, maybe 50 years from now, we will be counted among the best universities in the world, kind of a thing. I think that potential Indian universities have, and I hope we will realize that potential. And if you look at, for example, any higher educational institution, the institutions need to serve three purposes towards the society. One is education. Of course, we need to impart the best quality education. And here Indian universities are indeed doing a good job. The education quality in many of our institutions is, for the price that the students pay, is pretty good by any standards. The second aspect is the knowledge generation. Now, whatever happens, whatever is taught to the students is what is available in the textbooks, but these textbooks need to be continuously rewritten based on the new knowledge that is generated. That is where research plays a role. So therefore, our institutions, some of our top institutions are also, very good places for research, and that feeds to the education, and therefore education and knowledge generation always need to go hand in hand. The third aspect where we are pretty poor is innovation. Now, what is innovation? Innovation is all about generating value for research. I might have written large number of papers, but if somebody asks, what is the value you have generated out of your research? And if I cannot tell you a few tangible outcomes, it only means that I am a good researcher. That fact nobody can take away from me. But whether I am a good innovator or not is a different kind of a question. Therefore, anything that generates value for research immediately becomes innovation. And that is where the product development, that is where technology development, these aspects will come in. And this is where I believe Indian universities are pretty poor right now. But how does the knowledge become innovation? Knowledge becomes innovation when this R&D becomes relevance and delivery. Meaning whatever problems that you pick up, there needs to be a relevance to that problem, to the society that you live in. And eventually, if you develop a solution that needs to reach the people who exactly can make use of that, sort of a, sorry, who exactly need to make use of, whatever technology, whatever product that we develop. So therefore, if you look at the relevance aspect of that, I think, I see many people in our institutions, we're all now in this month, for example, the Delhi air quality is so poor, right? And I can be working on the air quality in London, air quality, somewhere else where data is easily available. I might be publishing lots of good papers on modeling the London air quality and all of that. That can be good research. There is nothing wrong in that. But using all of that knowledge, if I can develop solutions for addressing the air quality in Delhi, right? That is when, that is when innovation happens. That is the bridge between knowledge and innovation. So once you bring in that relevance, then you are innovating. And similarly, once you develop a solution, how do you reach it to the society? Either you connect with the existing industries and then they take up your solutions and implement that, or you start your own companies. Now, the startup culture has really been booming in this country. All of us have excellent incubators. Now, through a startup, you might be able to take your technology, to the people, and that is another mode through which we can actually deliver our solutions to the society. So therefore, relevance and delivery, these two aspects are very important for the knowledge to become innovation. Now, this is exactly, what this is my own way of my own informal survey of academic institutions. When I look at, where do our PhD students pick up problems, depending on which institute I surveyed, I see anywhere from 70 to 100 problems, so 100% of the problems originating in the library. And I always say that any problem that originates in the library has a very high chance of ending up in the library, because, it may never see the light of the day, but it will be a paper that somebody will cite, somebody may use somewhere. But otherwise, these problems which originate in the library end up in the library again. But the one way to pick up problems, therefore, is by observing issues in the society. I think that is where at IIT Delhi, a few years ago, we started immersion programs. We started sending our faculty and students to places like AIIMS and, work with the medical doctors and see, what are the challenges that the medical doctors face in their day-to-day lives. And then we started an initiative called GRIP, which is the grassroots innovation program, where we have students coming from all over the country. Now we ask students, to pick up a problem in their local region, and then join hands with other students, other faculty in the institute, and we even fund that research. And by picking up problems from their local regions, we expect them during their stay at IIT Delhi to provide solutions to that problem. And with such kinds of activities, now from the places that the students come from, the places not only say that our people have gone to IIT Delhi, but at some point they should be able to say that by going to IIT Delhi, they solved the problems that we had in our place. I think this is the kind of a program that we started, which is called GRIP. And we also started village internship programs at IIT Delhi, where our students can go to villages and spend time with farmers or whatever they want to do in that village. And we facilitate all of those visits. And at the end of the 2 months in the summer, they come back with the kind of problems, and then they can implement solutions by using the resources available here. We also activated our humanities departments, and we tried to connect the humanities department, which I see, as a window to the society, because many of them are working on problems of the society, but they have no connect with the engineers on the campus. So we started a Grand Challenge initiative where the humanities faculty will lead this Grand Challenge initiative, but in the team, there will invariably be people from sciences and in the engineering disciplines. So together they identify a problem and develop a complete solution to some of these problems. So we started multiple such initiatives to connect with the society. And then we also started connecting better with the industry. And we started again multiple activities. The industry day, we started at IIT Delhi, where on that day, at least representatives from 500 industries come to the campus, and it's like an open house. They discuss with faculty. There are thematic presentations by faculty members, and that has made a huge difference for the institute. And then we started multiple centers of excellence with funding from faculty. About 3.5 years ago, we started the Professors of Practice program, where industry professionals can come and teach at IIT Delhi, and they don't even need to have a PhD. All that we look at it is, because they have been working on a certain problem for a long period of time. They have become experts in that area, and that expertise is what they bring to the institute, and they collaborate with faculty and teach students. And the Professors of Practice program at IIT Delhi has actually worked very well. And I see that the UGC has implemented something similar on the lines of what we have done at IIT Delhi, sort of thing. And then we also started joint appointments with industry at IIT Delhi, and we are encouraging faculty to do sabbaticals in the industry. And we started a program called FIRE, which is it stands for Faculty Innovation and Research Driven Entrepreneurship. That is the FIRE program, and we started it about 3.5 years ago. And where we said, if a faculty member has developed any solution to any problem, they can defend that problem to the solution to a committee, and institute will give them 50 lakh rupees as a grant, and then whatever support that is required, so the faculty member can incubate a company out of that research. And through that program, we are trying to convert many of our faculty into entrepreneurs. I know nobody is stopping them from doing that, but until we launched the FIRE program, there was no incentive for faculty to do that. They all want to do it, but then they don't know where to start and all of that. And through this FIRE initiative, now many faculty are coming forward and then utilizing this support available from the institute, and and then connect with the right people on the campus so they can incubate a company out of that. And we now have in some departments, every 5th faculty member at IIT Delhi has a startup, and which is again a very successful startup with products launched in the market and all of that. So converting the faculty members into entrepreneurs has the advantage that every faculty member will have PhD students. So that culture will spread in the campus, and more PhD students will then move forward. And we even created a PhD incubator for them. This stands for Platform for Harnessing Deep Technologies. Through this PhD incubator program, many PhD students can use the resources available to start their own companies. So that again is way for a deep tech innovation to happen on the campus like IIT Delhi. Some of these programs are working very well. Similarly, connections with the strategic agencies. We connected aggressively with DRDO. About 4 years ago, we started a center with the DRDO help, Joint Advanced Technology Center. Today, there are like 100 faculty members, about 150 PhD students at IIT Delhi working on DRDO-defined, DRDO-funded problems. And DRDO has actually funded, almost like 300 crores at IIT Delhi to work on some of their problems, some of the challenges that they are facing in development of, certain technologies they are doing for the forces. And similarly with ISRO, we started that. So this is how we would like to see more and more students to pick up problems rather than library being the only source of generating problems. And this has brought in a huge transformation on the campus. And I call it an idea factory approach. And in the idea factory approach, the goal is to bring unlike minds together, and people who don't think like you, people who don't behave like you, these are the people we need to bring together. I call the unlike minds basically, people with different cultural backgrounds coming together, like joint degree programs, international students, international faculty, even professors of practice. This is like the unlike minds. The different disciplinary training. We started 9 academic units, new academic units at IIT Delhi in the last 6 years. All these academic units are multidisciplinary kind of centers. And we also connected IIT Delhi to all these institutions individually through a program called FIRP, Faculty Interdisciplinary Research Program, where if any institute wants to collaborate with IIT Delhi faculty, IIT Delhi funds its faculty, and this institute can fund their faculty. And through that initiative, the 2 institutes faculty can collaborate with each other, with the condition that after 2 years of working together, they have to write joint proposals and get some external funding. And at IIT Delhi, for example, we invested almost like 20 crores on this program to fund our faculty to collaborate with faculty with other institutions. This is the MFIRP program. And that, of 20 crore investment, we have been able to raise almost 200 crores of additional project grants, because these faculty connecting with each other are able to write much better proposals, venture into newer areas, working on the right kind of problems. That has made a huge difference for the institute. The other unlike mind I say is people with different attitudes coming together. That is where the industry collaborations have definitely helped us. We have now a research park, which we inaugurated a few months ago, industry day, process of practice, and working with the DRDO, all of these people, that has again made a huge difference. So once you generate ideas, the implementation of this idea to generate a complete prototype is where we have created an ecosystem for high-tech startups and creation of central facilities, and the FIRE program to encourage faculty to start their own companies, and PhD incubator for PhD students to do the similar kind of a thing, student startup action plan, early stage ideas we fund for the students, with the hope that if some of them become Flipkarts and Snapdeals in the future, or Googles of the future, because you are doing this funding as an equity investment, all of that money will come back, multi-fold kind of a thing. We also started an interesting program called 1, 2, 3, 4 Discover and Learn. One thing I noticed in our academic institutions here, every student who joins starts a research problem, takes it up to a certain level, then the time comes for the student to graduate, and that problem will remain unfinished. And the next student comes, again starts at some point, ends at some point. So we said, can we do these problems in a relay mode? So at IIT Delhi now, particularly using our undergraduate students, we started a program where in every group, there will be 4 students, 1 student from first year, 1 from second year, 1 from third year, 1 from fourth year. And when the fourth year student graduates, a first year student comes in, and then they work on a problem which has a societal relevance with support from the institute. And these are all done in a relay mode. And these projects, which we started a few years ago, now have all become products. In fact, some companies have come out of these initiatives, and every year we organize an exhibition to showcase the 1, 2, 3, 4 Discover and Learn projects, and that has become very popular among the students. And so these are some of the things where that encouragement for startups on the campus has definitely boosted, whatever that we have been doing so far in this campus. And this has definitely made a huge difference to IIT Delhi. For example, sponsored research income has gone up by 4 times, and we have filed 500 patents in the last 5 years, while in the previous 55 years, we filed close to 500 patents. So what we did as patenting in 55 years before is what we could do in just the last 5 years alone. I think that, and then multiple new initiatives, at least 350 industry projects on the campus. I think that connect with the external bodies, who are through that idea factory kind of an approach has made a huge difference for IIT Delhi, as some of these numbers show. Even our research funding has gone up by 3x kind of a thing. And so today we are in touch with over 275 companies as against about 50 companies 5 years ago, sort of a thing. So I think these are some of the things. Even during the COVID time, a lot of innovation happened because we just told people, this is the problem. COVID is the problem during COVID. Nothing else matters. Whatever you do, right, institute will support you. But finally, you should be able to put out a solution into the market. And once we gave that challenge to faculty, so many innovations came out of the institute. The world's most affordable RT-PCR kit, and then the rapid diagnostic kit, which is 50 rupees, and over 10 million masks have got sold, during the COVID time, which came out of IIT research. I think all of these things happened because we defined the goals for them, and then we provided them whatever resources that are required. And then after that, there was no stopping, any of these people. So the point here is that expertise and the ability to exist in our institutions. All that is required is to tie up all that expertise to a problem. And once you tie it up to a problem, I can tell you, wonderful things can happen out of our academic institutions, as COVID has actually shown. And then, then going forward, if you are looking at what are the kind of research areas that we need to innovate on, I call these 5 technology platforms. These platforms will have applications, implications in almost every walk of life. I mean, everything that you do in your daily life will be impacted by one of these technologies. So these are what I call the platform technologies. I call them the 5 Ts. What are these 5 Ts? The information technology, where India is already a world leader. our IT exports are as much as what Saudi Arabia exports as a crude oil. So therefore, we are one of the world leaders when it comes to IT. Similarly, the biotechnology, India is doing very well. I mean, we are after all one of the few countries which could develop their own vaccines, and with much higher efficiency. We were able to control COVID much better than China for that matter. And the credit should again go to the efficacy of our vaccines and all of that. In the nanotechnology, we are ranked third in the world right now. But this is one technology where converting that knowledge into wealth is very critical. And that is something that we need to be doing. The fourth T is the cognitive technologies, where AI, ML kind of technologies come in. And that is where India is ranked fifth in the world right now. But this is again the place where we need to apply this knowledge to real world problems and gain some market leadership. The sixth technology is the quantum technology, where Government of India has already announced $1 billion kind of an initiative. And this is a strong tradition of basic research in India. And I think converting again that research towards developing quantum solutions like quantum computers, quantum communications, quantum sensors. In every area, the quantum technologies are going to play a role. So these are the 5 technologies. Every decade, a new technology comes on the horizon. And these technologies tend to transform almost every sector, in the industries and in our personal lives. And so that started in India for IT. But we haven't, the BT also we have done very well. But these are the 3 technologies where India needs to gain a market leadership and become a torchbearer for the rest of the world, like what we have seen with IT and BT. I think the other 3 Ts is also very important for the country. Now, having said this, let me use the next 10 minutes that I have available to talk about my own personal kind of a journey. And for example, I joined IIT Bombay way back in '98, August '98 to be precise. And I came back from the US. And most of my research problems were, the problems I was working in the US. And prior to going to US, I was in Germany. So most of my research problems at IIT Bombay were basically my PhD and postdoc problems. And I worked on it for almost like 7 years kind of a thing. And I wrote lots of papers, published, and filed a few patents as well. So I was doing very well in my research. But around 2005 kind of a time frame, I asked myself a question, if I wanted to work on these problems, which are like, relevant for the US industries, why did I even come back? I could have as well stayed in the US, done a similar kind of a research, and I would have earned much higher salaries and all of that. So once I started to introspect that, the reason why I have come back to India is not to work on American problems. I want to do something, which the country can benefit from. So once that thing dawned on me, then I started to very consciously look for problems in the society around me and see what I can do to address some of these problems. And if you are looking for a problem in India, I always say that India has all the problems of the world. You really don't need to look at any US journal or anything. Just look around you, you find those problems. The question is, how do you convert those societal problems into projects? How do you execute these projects? That is where one needs to be, one needs to gain that kind of an expertise. For example, India needs technologies for youth to excel and acquire skills. Almost 10 million people are joining the labor force in this country every month, and we need to generate lots of jobs for them. Agricultural sector, hardly any productivity exists in the agricultural sector. Close to 50% of people work in agriculture. Their contribution to GDP is very low at 17%. You need a lot of innovation technologies to improve the productivity. The healthcare is a major concern. Rural healthcare infrastructure is hardly existent. In India, for example, 22 million people are pushed below the poverty line due to healthcare expenditure. I think we need to use a lot of web-enabled means to service these people in rural areas. And similarly, you have security is a major concern, energy is a major concern, the water is a major crisis, because we have only 4% of world's water resources and 18% of world's population. So each one of these is a problem, and I can tell you as a researcher, you can spend your lifetime solving some of these problems. So once I looked at some of these, I then started to work on what is that I can do in some of these areas. And, I come from a CMOS kind of a background. Most of my research is towards the mobile phones, improving the battery life of mobile phone, including, making mobile phone circuitry, the power more power efficient. So all of these were the problems. And when you compare us with the mobile phones, a human with the mobile phone, we have, for example, 5 senses that we all know: the sight, hearing, and touch. After all, mobile phones also have excellent cameras. They have excellent microphones. They have excellent touch sensitivity. In fact, the electronics touch sensitivity is now so good that people can perform surgeries 100 kilometers away. Using the 5G technologies, a lot of those remote surgeries will become possible. Now, and then there is also another technology which one usually doesn't talk about is in our brain, which is the GPS in our brain, to give you a sense of location. And that mobile phones also have very well. The 2 technologies which we humans possess, the smell and taste, which the mobile phones don't have. Electronics cannot smell things. Electronics cannot taste things. Now, the question is, can we develop platforms to make mobile phones, smell enabled or taste enabled? So one of the problems I took up was the smell sensors. And why do you need smell sensors? For example, at airports and every place, you find all these sniffer dogs, looking for narcotics to explosives to everything, right? So if you can have an electronic system, you can actually make things much easier for the security personnel. So that was one of the problems I started to work on. So I think the point here is look for a novel kind of a problem which can make an impact. And then I started to work on, and when you are deciding to work on any problem which has a relevance to a society, you also need to keep the cost point in mind. For example, if you look at the World Bank Atlas, this is something I downloaded from the web, from the World Bank, and you actually see, the lighter shades here are poorer countries. The darker shades here are the richer countries. Now, if you see, the world is not actually a rich place. We tend to think that, everybody can afford an iPhone and all that. But over 3 billion people on this planet live on less than $2.50 a day. And less than $2.50 a day. 80% of humanity lives on less than $10 a day. So $300 is all the money that they make in a month. So that is what 80% of humanity, close to the 4 to 5 billion people actually make in this world. So when you are developing solutions for them, you need to see, what price point the solutions will appeal to them. And that is where, we always need to keep in mind while executing any research projects of this nature. One of the first problems I took up at IIT Bombay in that mode was, developing a low-cost cardiac diagnostic system. One of the faculty members at IIT Bombay during MTech interviews, started to feel very uneasy, sick and all that, but still continued with the interviews. And then after a day realized that, he actually, when the pain became a little bit difficult to bear, we took that person to the hospital, and then the doctor said, it was a heart attack, and the person was actually going through the myocardial infarction, and then, all the care was provided to the faculty member and all of that. That is when the doctor said, can you guys not develop a technology where if somebody has a chest pain, a simple blood test at home should be able to rule out any heart-related problems, by looking for certain proteins in the blood, like the troponin, myoglobin, CKMB kind of markers, because these markers are very selective to the heart muscles, the myocardial infarction. So therefore, the doctor said, can you not develop a simple lab on chip kind of a thing, where with a drop of blood, we should be able to measure these markers. So when you are feeling uneasy, you do these tests for the blood sample, and then that chest pain could be because of other kinds of reasons. You have nothing to worry about, kind of thing. But if this blood test becomes positive, then you need to rush to the hospital. The earlier you come, the better it will be. So that's what doctors told us. And then we started working on that. We actually worked on a top-down kind of a fashion. So we said, you take the blood sample, you filter it out. So we gave it to a group to work on the blood filters, the blood to serum generation. And then we had microfluidic channels for monitoring different markers, the biosensor array. So we had multiple departments, at least 6 departments were involved at IIT Bombay to actually develop this entire product. Then the complete electronic system, this is like the glucose testing kit, where you have a strip and then a small instrument, and basically the strip in this case can detect those markers in the blood, the troponin, myoglobin, and CKMB kind of markers. And then we started working on the platform development, and we started to work on a cantilever-based sensing, a nanomechanical sensing platform, where you put the antibodies here. these antibodies bind to the proteins in the blood, the reaction is what we can electrically detect. And because the price point was critical, we said 100 rupee test. Therefore, the kinds of materials that went into developing this platform became very critical. As a result, since we were always worried about use of expensive materials, the technology became very novel. While 99% of the world was working on silicon-based platforms, we said silicon is too expensive for a disposable application such as this, and we started focusing on the polymer-based nanomechanical cantilevers. And to our surprise, we found that we started a new area in the MEMS field for the polymer MEMS, and anyone writing papers on polymer MEMS cannot miss any of the papers that we have written. So basically, the research became more exciting because we set ourselves the boundary conditions of the price and other sort of factors, and that made the research more interesting. And then we were able to publish lots of good papers out of this. Since I would run out of time, I will skip some of this, but a lot of technology went into that, and we showed world records in some of these technologies, and then we were able to put all this together, the electronics to the biosensing and all of that, to put together the first myocardial infarction sensor. We call it iSense, the infarct sensor, and this is how the cartridge looks like. This cartridge connects to this system to measure the biomarkers, and then we incubated a company, NanoSniff Technologies. We transferred this technology to them, and after we transferred this technology to NanoSniff, because it's a healthcare related product, the hospital trials and other things, took time. And during that time, in IIT, we then started interacting with the security agencies. There was a bomb blast in Pune, and that is when security agencies contacted us and said, since you have a sensing platform which can detect surface reactions, can you use that platform to develop explosive detectors? And then we started working on the explosives. We had no clue what it was, but then we had all the right-minded people from chemists to biologists working with electrical engineers. We built a multidisciplinary team, but the goal again was to develop the complete system and deliver it to the security agencies. The DRDO funding we received through various programs, including the Principal Scientific Advisors funding from the PSA office. And then we again worked on an innovative platform for developing these kind of sensors. We developed electronic nose platforms. One of the technologies we developed was an electronic nose. This is XSniff, where it takes in the air, and whenever there are any explosive particles found, and then it actually gives an alert to the security agency, so it can detect explosives. It can sniff basically the explosives in this particular case. And here again, but electronic systems don't know what smell corresponds to what. So you need to train the system. Just as we humans, we go through the recognition process, during our growing up process. I mean, as we grow, when you smell something for the first time, that, that smell corresponded to this, and your brain registers. And similarly, you develop a library of, what smell corresponds to what kind of molecules or systems. And that is what we did, for this system. We trained it to detect explosives, just as we do, just as humans go through the smell kind of a process. And then we actually, transferred this technology, and then we started working on multiple platforms for explosive detection, because we did not want to fail. If you put all your efforts in one direction, and if that technology doesn't work, finally, you would have worked for 5 years and nothing much to show. So we did not want to get into that mode. We had multiple faculty teams working on multiple approaches. And one of the other approaches we started was, developing a nanomechanical relay for vapor phase explosive detection. And finally, this led to something very tangible. And we actually, developed a kind of a micro sensor based explosive detection. It's a sort of a micro heater. What we essentially do is, from the ambient or from whatever is available, on as a traces on somebody, we basically collect about at least 10 nanograms of these particles, and then we cause a nano explosion. So once you collect 10 nanograms, these materials, we cause a nano explosion. How do we cause that explosion for the 10 nanograms of explosive? By essentially rapidly burning it. To burn it rapidly, we had to develop a micro heater which can heat up to 450 degrees centigrade in a matter of milliseconds. So that way, it immediately burns that explosive. And 1 second. So this, yeah. And then we then subsequently developed this technology as a product. In fact, this is the product which is currently available in the market. It's just a 2-minute video you might want.
An IIT Bombay incubated company jointly manufacture and launch Nano Sniffer, an advanced and affordable explosive trace detector. Screening visitors and passengers for explosives at various public or crowded spots have become the norm due to the increase in the terrorist activities around the globe. Every luggage and person passing through the security checkpoint is tested by the security officer to check whether they have traces of explosives on their surface, skin, or hair. Nano Sniffer proudly claims to be the first explosive trace detector in the world using micro-sensor technology. The micro-sensor of Nano Sniffer is made using micro-electromechanical system, MEMS technology in semiconductor fab. The sensor uses fabrication techniques such as lithography, etching, deposition, spin coating, and finally released to the microsensor. The core technology is protected by patents in the US and Europe. All of our actions leave trace behind, which is then screened by the security personnel. The security has to concentrate at the sampling areas that are likely to be touched by hands. In the case of a bag, this will include handle, buckle, and zipper. Post-sampling, the swipe is inserted into the system where microheater subjects the particles into rapid heating. In case of explosives, this triggers exothermic reactions which are picked up by the integrated temperature sensor of the microheater, thereby landing each compound in its own thermal signature. The algorithms use these signatures to distinguish between explosives and non-explosives. Further analysis of the algorithms help in categorization into the appropriate class of explosives. The follow are few Nano Sniffer features. It is the first microsensor-based ETD. It detects and identifies explosives in less than 10 seconds. Identifies and categorizes explosives into different classes. Can detect ng quantities of explosives traces. It detects all classes of military, conventional, and homemade explosives. It is portable and affordable. It gives visible and audible alerts with sunlight-readable color display. Nano Sniffer, explosives trace detection technology can be deployed at airports, railway stations, ports, malls, metro stations, corporate parks, hotels, and tourist spots. The goal is to intercept and prevent access of explosives trafficking. Nano Sniffer is 100% made in India product.
So this technology now is, in fact, Delhi Airport has placed order for these technologies. Next time when you pass through the Delhi security, you will actually have these kind of systems, doing the detection for you. And this is, one thing that has happened now. And but this is, almost 10 years of effort. We started this activity in 2010, 2011 timeframe, and we launched it a couple of years ago. Now it's all going to the airports and all that. So I think it takes time to develop such technologies, but continuously working on these technologies for a period of time is what is important. And we are also developing it now for the buses, as an explosive sensor node. And these sensors will be like, multiple sniffer dogs inside a train or a bus, which will be continuously looking for, presence of such molecules in the bags that one carries. And then we are trying to generate power, from the vibrations in the bus and a train, so that you don't have to use external kind of a power sources. And the idea is to just go and stick it at a place, and it will generate its own power and keep monitoring. So that led us to work on very interesting research problems in the piezoelectricity area. And then of late, about 5 years ago, after I moved to IIT Delhi, between IIT Delhi and IIT Bombay, we started looking at agricultural problems. And this again came about because of our interactions with the agricultural scientists and the farmers. So we did a lot of field surveys to understand what exactly the farmers require. And one of the problems we have identified is, the soil test cards that the government of India has given to the farmers, they require all of these parameters to be filled in at regular intervals. But a farmer doesn't really have easy access to these laboratories. So what we did between the two institutes, IIT Delhi and IIT Bombay, is to develop sensors for all these micro and macronutrients. That was the project. And in all these cases, our project proposal was very clear that we will develop 4 prototypes, one for volatile tracking, one for the pathogen detection, the diseases for the crops, the third for moisture, pH and salinity, and the other for the micro and macronutrients. And now between the two institutes, we have worked hard. There were large teams involved. In fact, we just launched the soil testing NutriSense, and the NutriSense can detect NPK in the soil, and it costs 10 times lower money compared to what is globally available, and 3x compared to whatever is locally available. This is the world's smallest NutriSense is what now SoilSense has developed. And now we are training the village level women particularly who can do these tests for a set of villages, and that can become their livelihood. And they are trained to do these soil tests because the tests are pretty simple. And we also have other kinds of soil moisture sensors and other things. We have the SoilSense. We started this company SoilSense about 3 years ago based on our research. And now SoilSense is doing very well. And they have tested these technologies on multiple crops. They are currently working with all of these big companies which have interest in the soil. And now they have been able to raise funds and recruit people. In fact, the BIRAC grants from DBT have been very useful. In fact, some of these Dr. Manju Sharma encouraged during our time, and these grants have been pretty useful for both my companies. Both the companies survived initial phases because of grants from DBT, and then they were able to raise the private capital for their sustenance. Now they are earning revenues, so they are quite fine. And so in this mode, by identifying a problem, by bringing teams to develop the complete solution, we have in a way changed the culture at IIT Bombay, and now the same thing is happening at IIT Delhi. So now most of the research is becoming product oriented, and the NanoSniff is doing very well. That was my first startup, and the second startup was SoilSense, and the SoilSense is also doing very well. Both these companies now will be able to survive. So innovation to me is top-down product-oriented approach. I think that is very important. And on the platform development, many times people ask me, if I work on product-oriented approach, can I write papers? I think the definition of problem is very important. You need to define the problem in such a way that you are not indigenizing something which is available elsewhere. That indigenization thing, we should leave it to ISROs and DRDOs. In academic institutions, I think we should innovate. We should look for a solution which is unique. The moment you define a unique solution, then the whole thing becomes very novel. Anything you do around that, can actually result in lots of good papers, and you can file many patents. And protect the IP as early as possible, because if you want to eventually develop a product, you need to protect as much IP as possible, so that when you start a company, the companies can raise investment. And there are lots of government funding schemes available. I think one shouldn't go to private investors for funding very early on and mature the technology in the academic environment. In my first company, we made that mistake. We started the company very early, so we struggled a little bit until they survived. But the second company, we did not do that. We developed the complete technology, and when we started a company, within 3 months, they were actually able to sell things. So that was one learning from my first startup to second startup. And they utilize the government sources of funding for the company initially. And thanks to our academic leadership provided by Professor Manju Sharma, others, there are multiple Government of India schemes now for startups, I think, which is what we should make use of, at least in the initial phases, which is less equity dilution. And I don't believe that professors and students alone can build a company. You need a team. So that is where we have in both the teams, management experts as part of the team, and they have done much of their job of sales and marketing and other things, and work towards the value of equity, not fighting for the equity. Because I see that in India, when people come together and do any such activity, I think that those internal problems will often make things difficult for the company. So I think we need to, in a team, what matters is how good you are for the team, not any other way. So I think that's what needs to happen now. And we must involve students in the enterprise. Both my companies are run by my ex-PhD students. They are the CEOs, and they are running the companies very well. And now they have a big team of people. So I don't even interact with the companies on a daily basis. Only through the board meetings and other kinds of things I interact with them, and look for areas where there is a great domestic market demand and where there are fewer controls and all of that. Fortunately, India is a big country, 1.3 billion people. And even if you, develop a technology which, some section of population will require, you can, survive and you can actually build a mega enterprise. That's what we are trying to do. I personally feel the three things are important: passion. Of course, unless you are passionate, nothing like this will happen. The patience, we are in a generation where you want instant gratification. You want results in 1 year. That's not going to happen in the deep tech area. Whatever I presented to you is a solid 10 years of work, and where there are at least tens of PhD students who have worked on these problems to mature things from a concept stage to a final product. So that patience is required. And then the perseverance. There will always be, problems along the way, but you need to persevere and then ensure that eventually things reach the market. So I think these are my experiences, but I do see a lot of talent, available in our academic institutions. If we can tie all of that up with the right problem definitions for them, I think this country, will be a global leader in technology development. And the next decade, I think, is very critical for this to happen. I will stop here. Sorry, I have taken a slightly longer time. Thank you very much.